Hello everyone, welcome to Let's Code. Myself Karan Rana here back again. So today in this video or in this session, we are learning about something interesting and something more important that will make you interview clear and help you to crack the company easily, either in the on campus or the off campus. So today we are discussing that what are the key concept, and in that key concept, I'm discussing in this session that is in part one. I'm only covering the 10 coding design pattern that will help you to master the DSA for your placement in the next coding interview. And that will help you trigger the how can you approach towards a problem and how can you think about the problem. So in this video, I'm taking the things from the scratch level so that you will be hard enough, you will be prepared enough for the every coding questions in the DSA. So what we'll be discussing? So we are discussing the coding design patterns problem that we are discussing so that it will help you to prepare for the next coding interviews. Next, what it will does after you covering all of the things, your skills will be strong, your solving skills will be strong. You will be easily identify the problems, and based upon the problem identification, you can approach toward the what type of coding patterns you should apply to that problem. So let's go to the Google Doc I prepared for you, and we can discuss this thing step by step. So today in this session I am covering only 6 to 7 topic. In the next part 2 I will discuss another part. So let's start discussing with that. So so in this sheet you can see that I already prepared you for that. It contains a 20D essential coding pattern to ace your next coding interview. What does this talk contain? It will contain all the coding interviews that would require a lot of graphs of algorithms and data structure. And it's actually the keep an eye that will track the problem based on the patterns. So you can see currently the market is already tough, and the DSA problems are actually harder day by day. And you, if you are doing giving the contest regularly, on the lead code, code chef, or code forces, you can see that the problems are become trickier and harder enough. And you need some time, and it will take huge amount of time to solve that, and it will take too much of thinking. So before covering that, because there is lack of thing that in that you're lacking, that you're not understanding the problem, you're not understanding the pattern, and you're not understanding the graphs of the questions. So in this doc, I'm prepared you for the thing that you take it as a practice and take it as a memory reader so that you can easily grasp up the problem that will ask in the interviews, in the OS, in the company OA, either in the off campus or on campus. So let's start the thing. So the first pattern is the two pointer pattern. So the two pointer pattern actually is a very famous and the very common pattern. And we generally use this problem when we have to find the sum of something that array or and the sum of finding the duplicates or something, or finding the what's it? You can say this is a two pointer problem. You can find in the two sum or three sum problems. And the most commonly design pattern that is used in this two pointer is the on the problems or two sum and three sum. So the two pointer technique is actually it's a clever strategy used in the algorithm design. Particularly when the thing is that when you are dealing with the data structure like the arrays and the linked list, that means when you're dealing with the questions having the data structure of the arrays or linked list, the two pointer technique is most cleverly used. So suppose you have two fingers and you place each at different end or position of an array, and these fingers or pointers can traverse through the array, helping you to compare such and even manipulate the data efficiency. So you can identify the two pointer problem as a real life example that so you have the two fingers, you place one at another end, another at end, other end, and you have to start traversing from the right in or left in, and it helps you to compare the value, search the value, even you can manipulate the data with that. So you can see that I have taken an array that will take 1 2 3 4 6, containing a pointer at the right left in and containing at the pointer right in. So this is actually a two pointer approach method of problem solving. And what is the usage of two pointer of this problem? So the usage is, this is used in the order data structure. So this pattern science when applied to the ordered array. What do you mean by the ordered array? That means your array will be sorted. If the array is not sorted, you need to sort according to the problem description you have given in the either in the context, OA, or anywhere else. So it applies to the order as list, allowing for intelligent position-based decision that can significantly optimize the algorithms. Next, efficiency. So by using the, because in that approach, if you want to traverse the two pointer, if you suppose we are solving about a two sum problem, we need to use the two nested loop, because we need to first travel to the first loop, then we have to go through the eh, under the loop so that we can traverse to both the condition meter. So by reducing the needs of the nested loops, the two-pointer technique helps in achieving the linear time complexity, making your algorithm faster and more efficient. So, what is the pros? So, algorithms are suppose pros and cons both. So, let's understand the pros and then we can go toward the cons. So, the pros is that it achieves the one complexity, that is linear time complexity for the problem that might otherwise takes O and squared time complexity. Next one is simplicity. Once you have mastered with that algorithm, you can provide a straightforward and elegant solutions. Next, what is the cons of this approach? So the applicability. What do you mean by the applicability? The applicability is that it will be mainly beneficial for problems involving sequence or intervals. Initial complexity, it might take some time to get the hangs of this pattern and to understand where to how to move the pointer, because there are some cons that you don't know that where to use and how, so it will take time to build in your mind that where to use and how to use. So that's about the two pointer design pattern strategy for the problem solving in DSA. Now we have the next pattern solving strategy that is mostly used in the array and using the 2D array, that is the island matrix traversal pattern. What do you mean by the island matrix traversal pattern? So the island pattern, also known as matrix traversal, it is a technique that is used to navigate through a 2D array or matrix. The what is the primary goal of it? The primary goal is to identify and the process continuous group of elements, often refers to as island, and this pattern is particularly useful when you need to explore and manipulate grid-based architecture. And this type of pattern you can solve this question. You can find this problem on the uh, 2D array questions, or some of even the graph problems like the land and the sea problem. So in that case, we have to use this pattern, that is the island matrix traversal pattern, or you can say the matrix traversal pattern. So you can see that there is a grid having 1110, 1110. So this is actually the visitor and non-visitor thing. So what is the usage of this? So the first usage is that it will be used in the grid based problem. That means when you have the problem related to the grid or finding the connected components or regions, we can use this pattern. And this pattern is mostly used in the graph problems, because we need to traverse through the grid, a 2D array, or do the traverses. So we need to use this pattern. Next, in the continuous element. So it is usually ideal for the situation where we need to group together adjacent elements that share a common property. So if we have the problem having will share a common property, we can use this matrix pattern for solving the DSA question. Next, we have discussed about the pros and cons of the two-pointer approach. So this is also has the pros and cons. So let's understand the pros and cons of the matrix traversal pattern. So the first pros is that it provides a true way that will explore all elements in the grid. Next, it can be versatile. It can be used in variety of problems. We can solve a variety of problems related to a 2D array by this pattern. Next, what is the cons? It can be more complex because it will be because we need to traverse through the whole grid. It will be like more complexity because we have to traverse through rows, column. It will become more complex. So next, what is it? It requires more additional space for the recursion queue stack for the breadth first search and depth first search traversal. Since I've already discussed that this type of coding question pattern actually asks are mostly used in the graph problems. So you can see the cons of this problem that using this pattern is that it requires more space for the recursion queue stack for the breadth first and depth first traversal. Next approach is the and next coding pattern is the fast and the slow pointer. So the fast and the slow pointer technique involves two pointer traversal traversing along a data structure that has different speed. I gen I also a fourth star coder and I know this type of problem will be mostly used in the linked list scenario. And the linked list there will be only 13 questions that will be asked in the interviews and these questions are only based on the fast and the slow pointer. Or you can call these are the rabbit and the tortoise problem. As the driver said that rabbit and tortoise problem coding pattern or you can call it the fast and the slow pointer approach. Next, this ingenious approach is particularly used when identifying cycles. Next, it will be finding the middle elements and it will be solving other problems that are related to the linked list and array. I already discussed this factor that this type of pattern actually most in the use in the problem related to the linked list and the array. So you can see that this is the cycle. This is the 1, 2, 3, 4, 5, and this is the head. So you can say this is the head of the linked list. When you have to find the middle elements of the linked list, when you can find out the cycle in the linked list, you can use this fast and the slow pointer approach for the problem solving of the problem based upon the linked list. Next, what is the use of this? So the first usage is that it will be used for the cycle detection. Next, it will be used for the finding the middle elements. Next, it will be based on the problem specific solution. That may will like the finding the starts of a cycle in a linked list. Next, what are the pros and the cons? What is the most efficient approach of this pros and advantage is that algorithm is that and this coding pattern is that it takes no extra space and it will take O1 space complexity. Next, it will be applicable to a variety of problem and making it a versatile pattern to know. Next, what are the cons? We need to understand how to move the pointer and what speed can be trick at first. Next, specificity. That means while versatile, since it is versatile, but it is mostly beneficial for the problem that are related to the linked list and certain array problems. So that's about the fast and the slow pointer method coding pattern or the tortoise and rabbit method of coding pattern. And I generally use this problem especially for the problem that are related to the linked list data structure. And this is the best approach for solving the problem based on the data structure that is the linked list. Next, and one of the most famous coding pattern that is called a sliding window approach. What do you mean by sliding window approach? The sliding window approach involves creating a window over a partition of data or a portion of data and sliding it across to solve the problems efficiently. And this technique is particularly useful in the array or the list based problems where you need to find or calculate something among all contiguous subarray or sublist of a given size. So when you have the problem related to the contiguous subarray or subarray problem type, you can easily use this approach that is a sliding window approach. because it creates a window, and after that window it calculates the sum. It will take count anything. So you can see in that figure that it will take a slide. After that you can slide one element forward. So where is the usage of this sliding window problem? So the practical use of this sliding window problem is that the first use is that contiguous subarray. That means it will be ideal from the problem that will require to deal with the contiguous subarray or the sublist. Next, the variable size window. See, it can be adapted for the problem where the window size is not fixed and need to be adjusted based on the certain conditions. Next, it has some pros and cons. So the first advantage is that it provides a way to reduce the time complexity from the O(n) 0 and O(n) square to the O(n), that is the linear time complexity. Next, it can be used to solve a variety of problems, including the maximum sum, subarray, minimum sum, smallest subarray with a given sum, longest substring with the k distinct character. You can use this coding pattern in that type of code problems. Next, it has some disadvantage that you need to understand how to adjust the window size and when to slide. The window can be challenging initially and mainly beneficial for the problem involving contiguous and the sublist. So this is about the sliding window coding pattern approach. And our next approach, and that is the last for the today's session, that is the merge interval problem. That is the merge interval coding design pattern. So the merge interval coding design pattern is a powerful technique that will be deal with the when we have the overlapping intervals or the ranges. Interval the sorting and then merging intervals on a specific conditions. And this pattern is especially incredibly useful for a time-based problem, scheduling or range manipulation. Where is the usage? So it mostly used in the overlapping problems, interval scheduling problems. Next, what are the pros? It provides a clear and systematic way to deal with the overlapping intervals. Next, the efficiency in reducing the problem complexity and achieving the optimal solution. Next, what are the cons? It provides a sorting overhead that will require the intervals to be sorted beforehand, which could add to the time complexity. Next, it could be beneficial for the problem that will be especially focused on the intervals and the ranges. So that's about the merge interval problem. Merge interval coding design particularly suited for the problem that where we have given a range of numbers, or we have given a range of character, and we need to ask them to sort them. So in that problem, we need to use the cyclic sort design pattern or the coding pattern. So the what is the beauty of this pattern? So the beauty of this pattern lies in its ability to sort the numbers in place, utilizing the fact that the numbers are consecutive or have a specific range. So where is the usage? See, it be used in the consecutive numbers. That will be ideal for the scenarios where you have to find an array of numbers in a specific range, or you need to sort them or find the missing or duplicate numbers. Next, where you can use it in the in place sorting. So it will be used, or it will be provide a way to sort the numbers without using any extra spaces. Next, what is the pros and the cons of this? So the advantage is that it will be achieve sorting without no need for additional space. It will be adding to O1 space complexity. What is the time complexity? It offers a single, that is the linear time complexity solution to a specific range based problem or the sorting problem. What are the disadvantages of this coding pattern? So the it will be limited applicability. That means it will be best suited for the problem that will be involving number in a specific range or may not be applicable for other types of the sorting problems. Next, initial learning or curve. Understanding the cyclic sort patterns and knowing when to apply it, it can take some time. Next approach of the coding design pattern, that is the in place reversal of a linked list. So the in-place reversal of a linked list pattern is a technique actually used to reverse the element of a linked list without using the additional memory. And this is used by or this is achieved by actually manipulating the pointers of the nodes in the linked list to reverse their direction. What is the usage of this pattern? So that it will be used for the memory as efficient since we are not using the additional data structure, so storing that. So this pattern is actually the memory efficient. Next, it will be reversing sublist. That means it can be extended to the reverse sublist within a linked list, providing versatility in solving more complex problem. That means it can provide to extensibility. That means we can, if you have to find the in the linked list, we have to do the traverse something inverse, so it can be used in that scenario, and it will be more versatile that we can use it for the more complex problems. Next, what are the disadvantages and the advantage of it? So the first advantage is that it can be used in achieving the place reversal. That means it ensures the O1 space complexity. What is the versatility of this approach? So it can be used to solve various problems that are related to the linked list, including the reversing sublist and finding the palindromes. Next, what are the disadvantages of this approach? So it can be used in the pointer manipulation. That means it will require careful manipulations of the pointer, which can be error prone. And what is the initial learning curve? So it will be understanding how to reverse the pointer without losing the rest of the linked list can be challenged initially. Our next design pattern is the tree based tree breadth first search. So the tree breadth first, that is that BFS pattern, involves a traversing a tree label by label, ensuring that you visit all the nodes at the current depth before moving on to the nodes of the next depth level. And this is usually implemented using a queue data structure. So we can see in the graph figure that we can do the travels in the first level, we can do the travels in the next level, we can do the travels in the last level. So practically usage of this coding pattern is that it can be used for the problem that requires you to traverse a tree in a label wise order, or when you need to perform operation on nodes at the same depth. Next, when you have to find the minimum depth of a tree, you can stop the traversal when you find the first leaf node. So in that type of problem, you can use this method or pattern that is called the three breadth first search. What are the disadvantage and advantage of using this approach? So the advantage of this approaching this approach is that it provides the complete traversal. That means it ensures that every node in the tree is visited, and it provides a level order information. That means it provides information about the depth or level of each node. What are the disadvantages of this? So it provides space overhead, requires additional space for the queue, which can be as large as the number of nodes at the largest level. Next, what is the not as efficient for the depth related queries? For the problem data depend upon the depth information or depth first search algorithm, that will be marked insufficient. So when you have the problem related to somewhat DFS, you cannot use this approach. That is a TBFS. You can call it tree breadth first search approach. Now we have the next approach or next coding pattern is that tree depth first search. So the tree depth first search pattern involves a traversing a tree in a depth manner. That means you can go as deep as possible down one branch before backing up and exploring the other branches. This is the typically implemented using the recursion or a stack. Next, where you can use that, you can use this coding pattern where you have to find the path or check the existence of a path with certain properties. Next, usage that when you have the complex tree traversal. So you can use this approach when you have to do the traversal in the complex way, or you have the questions that have the traversal to be in complex order. So where you need to maintain a state or perform operation as you have to traverse. So it actually somewhat has advantage disadvantage too. So previously we have discussed the advantage disadvantage of the other approach. Let's discuss this approach too. So it provide the first disadvantage that it space efficient. That means for a balanced tree, DFS uses less space than the BFS. Next, it provides me the simplicity. That means recursive implementation can be more straightforward and concise. Next, advantage is that it can be less efficient for the wide trace. For very wide trace, DFS can use more space than the BFS and may not find the shortest path if you are looking for the shortest path in a unweighted graph. So when you have the problem where you have unweighted tree, you cannot use this approach, that is the three depth first search coding pattern. You have to use the BFS in that case. Now our the next design pattern or coding pattern, you can call it as coding pattern. This is called the two heap. So the two heaps pattern involving the two priority queue to maintain a running balance or median of a set of a numbers. That means one heap keep will track the small keep the track of the smaller half of the numbers, and other will keep the tracks of the larger half. What is the usage of this? It will the first usage that it will be running medium. That means it will be perfect for the problem that we need to find the median of a state set of a number as a number new numbers are added. Next, it can be used in the balanced partition. That means it can be useful for the problem where you need to maintain a balanced partitions of a numbers. Next, what are the pros and cons? So the advantage that it provides a way to efficiently find a median or maintain balance in O log n time. And what is dynamic? It can handle the dynamic data set where numbers are added over the time. What are the disadvantage of this? So it can be implemented can be more because the implementation of this approach will be more complex due to the need to first we need to balance the two heaps. Next, disadvantage, it requires more additional space to store the number in the heaps. So this is about the today, and this is about the part one of the how to make master in the DSA with learning about the 20 design patterns. So if you like this video, please like and subscribe to our channel and press the bell icon for the part 2.